recap. So, what is our project? It's the bomb-sniffing robot. What does it do? It detects bombs through a sensor array, and it allows the user to use it to receive this data on a graphical user interface. That way, so they can do what is necessary to avoid the bomb or move if they need to. And what else we talked about is the design that went into our robot, the hardware, such as the body of the robot, the camera, the sensors themselves, and also the software, how we're going to implement the GUI, and how we're going to send the data to the GUI. We also talked about our different designs, such as the stair climbing, not the stair climbing. Should we use a remote control with an LCD, or should we make a GUI? We also talked about the wireless, how we're going to transmit data, etc. And lastly, we talked about our risk, time, cost, testing, and we came up with that we're going to be able to go through this. We can apply for scholarships, we can go through different testing resources. So the impact of all of this is we're going to be able to get through this. We're going to be able to finish the project when we want to, and hopefully make it extremely successful. So, in all, we did bomb. And I'd like to open the floor to questions now.
Yeah.
Did you guys say that you moved from semi-automated to automated? Is that what you?
To non-automated.
To non-automated.
We're user control. The controller was the user input. Remember?
Yeah.
The controller.
Yeah.
Yeah.
Okay.
Yes.
What makes your project different than like the pre-existing bomb-sniffing robots out there already?
Ours, for one, has a graphical user interface. Is one thing. We also have it's more user-defined. It's customizable. For instance, if you want to look at, say, propane and butane, then you can actually look into those itself. And also, another big important thing is that our system is a lot cheaper. If we actually get this thing to work, then it's at 10 to 15 times cheaper than the actual packbot, which they consider as the best. Huh?
It's 75% cheaper.
75%
Because the other models are about like
it's like $50,000. And we're essentially doing the same thing except for maybe one thing which we can easily implement. It's the basis of it, so prototype stuff. Yeah. Yes.
How heavy is this thing going to be? Y'all mentioned that weight was a pretty big deal.
Most military soldiers are trained to carry about 80 pounds of weight, and so we're going to try to keep it within that frame of weight. So does that answer your question?
You're just going to try to keep it under? Well,
yeah.
I mean,
so all electronics are going to be lightweight. The frame itself is going to be the most important to keep it lightweight. So we're going to go to Home Depot and make sure that we're getting material that is that light, and we'll definitely be taking all of the weight.
Yeah, it's practically a function of two things: the power, which is the batteries, because that's going to be probably the most heaviest, along with the body. Depending on how strong we want to make it, we still want to keep it as strong as possible, but still light. So.
Are y'all going to make this thing modular? I mean, because if a track falls off,
right?
Are they going to be able to fix it in the field?
Yeah. We didn't mention this, but we are going to put in a user manual for the user, as well as on the GUI you'll have a link to our website that we'll have, and they can easily go and chat with one of our representatives if we decide to make this as a full product.
I mean, like in the field,
they're
getting shot at.
Well, yeah.
I don't want to chat with.
The thing is designed so that you can be far distances away from the actual site.
Okay.
So,
yeah. I mean, 300 feet is one football field, so you're quite a distance away from it.
You can find the place, I'm sure.
Yeah, you'll be safe.
You'll be safe.
Don't worry.
Yeah. So, what kind of device do you transmit the Wi-Fi signal? Because I know, like, the normal router is not that range, is not like 500 feet, like you said. So, what kind of transmitter are you going to use?
We're going to use a power complex of instrument. It is RF2500 and whatever you can probably Google it. And it's a wireless module. It's using 802.11b stuff. So, and it can easily communicate with almost any kind
so 8 to 11B is really low on bandwidth. It's like gig.
It's not.
And so,
It's 52 Mbps, right? It's 11
Yeah.
Mbps.
Yeah. That's plenty for video.
Have you looked into using the N protocol? I assume a lot of N. Is it just more expensive?
That's probably a lot more expensive though.
Yeah, it's expensive. That's why we're starting with 11B, and that's all we need for backup.
Yeah.
We'll just divide up the packets into 2 different packets.
Right.
So let's do that.
Oh, yes.
Okay, so, when you're gonna take the robot and, so the person's gonna be carrying it.
Mhm.
So then the person's gonna like put it down on the ground and let it go, or is he gonna put it where he thinks there's a bomb, or?
Yeah, we put it down, yeah, you can put it down right next to you, and then from there it's fully controllable from the, with the controller. So from there you can send it wherever you want to send it.
And on the graphical user interface, yeah, you have a continuous data stream that's getting to the GUI so that you can continuously build up the graph. So depending, obviously you want to find bombs, if radiological detection is going down, then you're obviously going in the opposite way of what you really want to do. So I mean, it's based off of that. It's more of a negative feedback loop, so it's all within the user and the car.
Yeah, and there will be a camera on top with a live video, so you can
Yeah.
actually see where you're going.
Exactly, yeah, and it's going to be video stream. Yes.
So, y'all are gonna detect these bombs, but what about, so say there's 3 or 4 bombs and one's already exploded. I mean, the chemicals would still be in the air. Would that impact your sensor readings?
Yes, it would. We haven't talked about that yet, honestly, but we can definitely take that into consideration.
But still, that's still a hazard, so that's what I was going to say. Yeah, that's obviously going to be harming people within a large radius anyway, so I mean, that's a good thing. You want to make sure that, hey, we just found out that certain place, this place here at coordinates, depending on what the GPS tells us, you can send an alert, so stay away from that, because depending on how high of a level it is, it's definitely deadly. If it's, you can die in a day or something, depending on how
Yeah,
much
and also when it detects such high levels, it's going to send an alert to you, like, don't go here.
Yeah, well, I mean, there are going to be a lot of different features that allow people to
Are y'all, with the camera, are y'all actually going to do like user I guess confirmation of a bomb? So, say there is high radiation and they go over there and they see like, oh yeah, there is a bomb there, or is it just supposed to be completely automated, I guess, in that respect?
None of the robot is automated.
We're not going to take care of any of that. This is practically just for knowing what's out there.
Okay.
Because if you go into that, then the system will get way too expensive and complex. Yeah. Just the basic features is what we're.
So you're asking if it was somewhat autonomous in nature, like it had some thinking of its own?
Well,
If it's
like,
Can we actually confirm the bomb?
the user's using it,
Yeah.
he's seeing the data, hey, the radiation's going up, but I don't see a bomb.
Yeah.
Like, how do I find this bomb? How do I know exactly where it's at so I can destroy it? Like,
That would be the camera. That'd be real time feedback. So we
yeah, that's what I was asking.
Yeah. Beyond that, yeah.
Okay.
Yeah.
Well, thank you very much.